Hello guys. So this problem is basically valid parenthesis. It's a very popular and very easy problem. Whenever we are taught basics of stack, we are given example of this particular problem only. So you can read the questions and then let's get started. So basically we just need to tell if our string contains valid parenthesis or not. There are these rules that it should open or exit and exit with the same type of bracket. It can't be that one parenthesis is parenthesis, another one is curly bracket, so this would return false in the case. Okay, so a better way, like you can think of solutions. What can you do is you can try keeping a counter of open parenthesis, open curly braces, open square brackets, but then you also need to make sure that just by keeping the counter and immediately decreasing the counter when you encounter the similar type of closing brackets, you can try decrementing it, and if at any point it reaches below 0, it will be false. However, that solution should not work in all the cases, although you can make it work, but it would be a more complex solution than what we can get via stack. So let's get started with writing a solution. So I'll define a stack, and since it's our characters, it's a character, our brackets, so we will define a stack of character. Let's name it as st. So now what is the basis of our solution? Whenever something is pushed on our stack, so for example, let's say that we encountered this string. So first we are at this character, the opening bracket, opening parenthesis. So we'll push it, and then we encounter the closing parenthesis. We check in our stack if the topmost element was an opening parenthesis. If it was an opening parenthesis and our current character is the closing parenthesis, then we pop it. And similarly, we do it for every type of bracket, parentheses, curly brackets, and square brackets. If at the end our stack is empty, then we can say that our parenthesis is valid. So we'll return true or false otherwise. Okay, so let's write it down. As I said, I'll first traverse my string. So when should I push a character onto my stack? If it's an opening one, right? So my first condition would be if my character is either the opening parenthesis one, either opening curly bracket one, or opening square bracket one. If these are my cases, then I'll simply push my character. And when can I pop for it? I have to pop by looking that my previous character was of the same type. So if I can say that my character, my current character is, let's say, of an closing parenthesis, then I need to check that my it should be and, because these both conditions should match. Then I should check if my stack dot top was basically equal to my opening parenthesis. Now what is one more condition on this? When can I not access my stack dot top? When my stack is empty. So a prerequisite of writing this if condition would be to first check that our stack shouldn't be empty. So I'll just write a condition here. If this is the case, and if this condition holds, this condition holds, only then I can say that let's not complicate it and just write individual conditions. If this is the case, then what I will do, I'll pop it from my stack because that pair has been matched. Alright, things clear for now. Let's now write this condition for other type of brackets. For my curly bracket and for my square brackets. Okay, till now things are clear. Are we missing any condition? Let's say that we just encountered a single closing parenthesis. Okay, let's say this is our input string. So it definitely won't go in this if condition, so it will fall in this else. Now in this else, it won't fall in this because my current character is a closing one, but my stack is empty, so it won't fall here, it won't fall here, it won't fall here. So if such a case exists, then we'll simply write return false, because it's a clear indication that a stack is not valid and we have encountered a closing bracket before an opening one. Okay, so at the end we just need to check if our stack is empty. If our stack is empty, then we return true, else we return false. Let's try running it. Okay, we are passing. Before submitting, let's discuss its time and space complexity. So the time complexity of such a solution would be equal to, what are we doing? We have a stack and we are traversing each character one by one. So it's just a big O of n, where n is the length of string. What is the space complexity? We are not using any additional space. Our space complexity is basically the topmost, at max the number of characters in the string, because that will be stored in our stack. So our space complexity will also be equal to big O of n in the worst case. Okay, let's try submitting it. And we get it accepted. Thank you.